where can you now use this, and how can you how can you now really practically apply this? We have seen four big phases. The first one is the selection of a treatment technology. For example, you are deciding on, should we put ozone here, or would activated carbon be a more suitable technology? You are in the phase of deciding which technology to put there on site. So the questions you have is, what, yeah, is ozone suitable? If so, what is the bromate potential? What is the cost and performance of this future full-scale installation? Typically, people put pilots on site. They run it for a couple of months to over years, and then they collect a lot of data to see what the performance is. We have actually been replacing completely complete pilot trials with this model by, again, feeding it with the real sensor data or the plant data. And this is what we call virtual piloting. So we do the virtual piloting on site, which gives you a very good idea on including these dynamics you will face in if you would put a future full scale on site. Of course, then if you have decided, okay, let's put ozone on site, you have to design it. Typically, design has two big stages. The first one is the conceptual design, basic sizing, basic ozone demands, basic estimations of costs. This is conceptual design. Typically, we use a very similar approach there. We built this full-scale plants or several full-scale candidate plants with different volumes. We test different ozone control strategies. Should we go for a delta UV, DUC proportional, flow proportional, maybe a hybrid of those? And you can run them through the model to have the conceptual design. So questions there are the size and of course, the performance of the installation and the cost. The second step of design is the detailed design. Before you build, these questions are quite different. You have been deciding on the capacity, you have been deciding on the size, but you still have to make some decisions on, okay, where exactly do we have to put the diffusers? Where exactly should we put the baffles? Should there be baffles in the first place? What is the shape of the reactor? Things like that. You can clearly answer them with CFD. So the questions we have there are related to transfer. What is your transfer? Can we optimize, maximize the transfer, baffle placement, mixing? Of course, your local hydrodynamics have a drastic impact on your local residuals. And I shouldn't explain it, right? It also has an impact on your local bromate formation and your overall bromate formation. So don't underestimate the importance of this second stage, because there are really a lot of wins to be made there still. And of course, once you have built it, you can use exactly the same model to run it virtually as a digital twin. So this means you have a computer next to your plant. Actually, it is fed with the same sensors of your plant, but the model predicts and gives you in real time your bromates, your CT, your cost, or your the removal of whatever amount of micropollutants. So this is the digital twin application. And you can see that they nicely connect. Once you have a model in the first stage, you can actually use it throughout the whole cycle. So this was just to bring it together, to structure your mind a bit, to help you seeing this whole forest of applications. But in the end, it's quite powerful. It's really digital twin application.